Hi, everybody. So I've had this problem sent to me in by a couple of students, and so I've posted the problem in the content tab, um, and I want to go through it. And it says I'm using a YouTube video, so I only have 10 minutes to go through this. So I'm going to do about half of the problem. All right. So you can pause this and read this, but basically it says in a course in statistics, a course in statistics is one of the most difficult at a local university. Because of this, for the past decade, the university has arranged for teaching assistants to hold frequent discussion sessions as part of the course. Since the inception of the discussion sessions, 55% of the students enrolled in the course regularly attend the sessions, and the other 45% did not. Students regularly attending the sessions have performed better than those not regularly attending. In particular, 60% of those students regularly attending the sessions receive a grade of B or higher in the course, while only 40% of the students not regularly attending the sessions receive a grade of B or higher in the course. Let D denote the event of a randomly chosen student enrolled in the course regularly attending the discussion sessions, and D bar, okay, now this notation that's used here in some of my videos, I've used D with a high C for D complement, or D with little prime, and I'll show you that in a second. The event that randomly chosen students did not regularly attend the discussion sessions. Let B denote the event that a randomly chosen student received a grade of B or higher, and B complement denote the event that the randomly chosen student did not receive a grade of B or higher. And we are expected to figure out the probability of D, B given D, not B given D, and then finally the probability of D and B, and the probability of D and B complement. All right, I'm going to move the video on you over to a board that I've done some prep work on. My apologies for this. Okay, so here we go. So first of all, we talked about D. D is all the people that have attended the discussions. D bar is the complement of D. All the elements not in D. In other words, they did not attend the discussions. You have B and B bar as well. Again, in my videos, I would have said something like D prime or D complement. Sometimes you'll see not D. Sometimes you'll see not D. I didn't know that Alex used that. So let's talk about this part right here. You're given that 45% of the people did not attend. That's the probability of not attending. And 55% of the people did attend. Okay. And then there's a grade breakdown that goes for those that did attend. And this is the conditional. This is conditional probability. And the way this reads is you get a B or higher given or assuming that you did attend. And it works out that that's 60%. And over here, you did not get a B or higher. It's the probability you did not get a B or higher given or assuming that you did attend. And so the proportions or the percents or the decimals that represent those probabilities are 60 and 40. Now, how do we determine this? The probability of attending and getting a B or better, the probability of attending and not, and really it works out to be, and not getting a B or better. All right, so we're gonna compute this, or show you how to compute these two. The bottom set of brackets are done the same way, but I'm going to leave those for you to figure out. So I'm going to scroll down here, and we're actually going to do, sorry, hold on. I'm going to set this up differently. There we go. So the probability of attending and getting a B or better. Now this is the multiplication rule, and I have a video, maybe a couple videos in the content tab talking about this. So the way it works is it's the probability of D multiplied by the probability of B given D. So if you look at the order, the D is first and then the D is last. and then the B lands in the middle. And it reads the probability of attending multiplied by the probability of getting a B or better given you attended. Well, and I'm fairly confident in one of my videos I talk about multiplying down the paths. And so if you follow this path, it goes 0.55 times 0.60. It follows the formula right here, so it goes 0.55 times 0.60. Do double check the decimal accuracy you have to go to, but that's how you get that one. And then if it's the probability of D and not getting a B or better, the probability of D multiplied by the probability of not getting a B or better given you did attend. And so it's 0.55 times 0.40. And traveling back over here to our paths, we go 0.55. There's the probability of D multiplied by the probability of B, not B, sorry, given D. And I hope that helps.